Welcome to your custom deep dive. Today, you've handed us a document that really pulls back the curtain on the magic of the software we use every single day.
Right, because usually there's this expectation of just, absolute frictionless reality.
Exactly. You press a button on your screen, a document converts, a PDF pops out, and we just accept it as a given.
Mm.
I mean, we rarely want to see the actual gears turning.
But stepping into the world of the people actually building these tools, well, it shatters that illusion entirely.
Yeah, it really does.
You realize very quickly that what feels instantaneous on the surface is actually a landscape of incredibly deliberate, sometimes frustrating, and highly personal choices underneath.
Which is exactly why the source material you provided for us today is just so fascinating. On the surface, this is a highly specific, very technical text.
Yeah, it's an excerpt from a developer diary titled Notes on Haskell Programming.
Right. Specifically, we're looking at part 135, published by an author named Ang on May 15th, 2026.
And, just seeing part 135 at the top of the page immediately sets the stakes.
Oh, for sure. 135 parts.
Right. We are dropping into the middle of a massive ongoing journey. The author is deep in the trenches of building something complex, dealing with a code base that has likely grown, well, way beyond its initial scope.
At first glance, I mean, Ang is just showing us a few code diffs, just the before and after of some Haskell syntax.
So there's a lot more there.
Exactly. Our mission for this deep dive is to extract the underlying philosophy of software development hidden inside those few lines of code. We're going to explore how developers coax silent, invisible systems into actually talking to them.
And the deeply stylistic choices they make to manage the psychological burden of complex logic.
To understand the problem Ang is solving, we need to look at the specific tool being built. Ang is working on a command line interface application.
A CLI app, right?
Yeah, a CLI app.
Mm-hmm.
And the goal is to build a feature that generates PDF ebooks using a modern typesetting system called TIPST. Okay, let's unpack this.
Let's do it.
Ang is building a PDF generator, everything seems fine, and then they hit a wall.
Yeah, and the wall is essentially a dependency issue because Ang isn't writing the document conversion logic from scratch.
Right.
They are relying on a foundational tool called Pandoc to do all the heavy lifting. Pandoc is basically the Swiss Army knife of document conversion in the programming world.
It translates almost any text format into another.
Right, exactly. By delegating that work to Pandoc, Ang saves hundreds of hours of coding. But that delegation comes at a cost, which is a total loss of visibility.
Because Pandoc's internal process is just a black box. You toss a raw file into it, and you hope a beautifully formatted PDF comes out the other side.
Yeah, you just have to trust it.
But if something breaks in the middle, or even if you just want to measure how efficiently it's running, you have absolutely no idea what's happening inside that box.
And if we connect this to the bigger picture, libraries like Pandoc do heavy lifting behind the scenes. This is one of the most fundamental trade-offs in software engineering.
Oh, definitely.
We build modern applications by stacking existing libraries and systems like building blocks. It makes development faster, but the moment you hand your data over to a third-party library, the application goes blind to the process.
Yeah.
The developer suddenly needs a window into that internal machinery to verify that the lightning they are routing through those pipes is actually going to the right place.
It kind of makes me think of dealing with a teenager.
A teenager.
Yeah, like by default, a teenager gives you zero information about their day. You ask, how was school?
Yeah.
And you just get a grunt. That is your default software library.
Okay, I see where you're going with this.
Right. If everything is fine, you get total silence. If everything is a disaster, you don't get a nuanced explanation. You just get a slam door, which in our case is a system crash.
That's actually a great way to put it. To fix that, you need a mechanism to coax out the details. And in software, this mechanism is called verbosity.
Right. You literally have to turn up a verbosity dial.
Yeah.
Like level 0 means you are only informed if the house is actively on fire.
Right, that is an error state.
Yeah, error state. Level 1 means you want to know if they fail the math test. That's a warning. Level 2 means you want to hear every single detail about what happened at lunch. That's your INFO. The system won't do this naturally. You have to force it to speak up.
So Ang needs Pandoc to speak up.
Yeah.
But the complication here is translation.
How so?
Well, the user running Ang's command line app might type a simple integer to set their desired verbosity level, like perhaps typing a 0 or a 1 on their keyboard.
Okay, yeah.
Pandoc, however, doesn't inherently know what a raw integer means in the context of Ang's specific application. Pandoc has its own strictly defined vocabulary for logging.
So Ang has to build a bridge. We need a way to map the simple numbers the user types into the complex vocabulary that Pandoc actually understands.
Exactly.
Yeah.
And the diary provides the exact function Aang wrote to solve this. It's titled Get Pandoc Verbosity. It basically acts as a translation dictionary.
Let's look at the mapping itself. Aang writes it out very clearly. If the integer provided is 0, the function maps it to the state error. If the integer is 1, it maps to the state warning. And for any other input, Aang uses an underscore symbol, which acts as a catch-all in Haskell, to map everything else to the state NFO.
The elegance of this function lies in its role as a boundary layer.
A boundary layer.
Yeah. Aang is taking a raw, meaningless input from the outside world, a literal digit typed by an unpredictable human, and translating it into a structured, safe state that the Pandoc library can ingest without crashing.
Wow. So it's turning raw human intent into machine vocabulary.
It creates a perfectly clean translation pipeline. The user types 1, Aang's code catches that character, assigns it the semantic meaning of a warning, and feeds that explicit concept into the deep machinery of Pandoc.
But a translation dictionary is totally useless if the system doesn't know it exists.
No, absolutely.
Knowing what to translate is just the conceptual part. How did Aang actually wire this new vocabulary into the application's brain? You can't just invent a word like warning and expect the compiler to magically absorb it.
Right, you have to physically alter the architecture of the code. This is where Aang's diary becomes highly instructive.
Yeah.
Because they provide the diff.
The diff, yeah.
Right, the exact lines of code that were added, modified, or deleted to make this work.
Let's dissect those granular changes. First, Aang had to change the imports at the very top of the file. They brought in set verbosity from a module called text.pandoc.
Yes, and they also imported the verbosity data type from text.pandoc.logging.
Right.
To a compiler, a new file is a blank slate. It is entirely blind to any concepts, functions, or types that aren't explicitly introduced. The application literally did not know what the concept of verbosity was until Aang wrote those import statements.
It's like bringing the actual dictionary into the room before you try to look up a word.
Exactly.
Once those words are in the room, Aang modifies the main function, which is called convert to ebook. Before this change, the function only cared about two things from the user, the input path of the file and the desired output format. But in the diff, we see Aang pry open those arguments to extract a third variable, verbosity v.
The pipeline is being widened. Aang is forcing the main function to accept this new piece of data so it can carry it downward.
And carrying it downward requires, well, the most significant structural shift in the diff. Aang rips out the old execution block, which was a simple statement reading case FMT of, and replaces it with a do block.
Specifically, Aang wraps the execution inside a runio command.
Get runio, which is huge, right?
That shift from a pure case statement to a do block under runio is massive in the context of Haskell. Haskell is a functional programming language, which means it highly prizes pure functions.
Pure functions.
Yeah, functions that just take an input and return an output without affecting anything else in the system. But logging information or reading a file or talking to Pandoc, those are side effects. They interact with the messy outside world.
So the runio is basically the application's way of asking permission to step outside of its pure mathematical bubble.
Exactly. It stands for run input output. By changing that block, Aang is explicitly telling the compiler we are no longer just evaluating data in a vacuum.
Right.
We are going to perform a sequence of actions that interact with the external environment, and we need to execute them step by step. That is what the do block facilitates. It sequences those actions.
So what does this actually mean for you listening? Why does it matter that Aang had to physically change function signatures and restructure execution blocks just to pass a little v variable down the chain?
It's a great question.
To me, it highlights how deeply interconnected software is. It's exactly like remodeling a house. You can't just decide you want a new light fixture on your ceiling and magically have power.
No, you definitely couldn't.
You have to physically open up the drywall, run the copper wiring through the ceiling, down the studs, through the floorboards, and wire it directly into the breaker box in the basement.
That's spot on. Data doesn't teleport. The infrastructure must be built to carry it. Aang had to touch the top-level imports, widen the function arguments in the middle, and rebuild the execution block at the foundation just to successfully pass a single 0 or a 1 to Pandoc.
The pipeline is successfully widened. The app is talking to Pandoc. The feature works. But then Aang pauses. In the diary, they step back and reflect on how they wrote that mapping function. They look at the aesthetics of the code.
Yeah, they reflect on the stylistic choices made to achieve the outcome.
Ang points out that they wrote the get Pandoc verbosity function using multiple function equations. That means listing out every single rule on its own separate line.
Right.
Line 1 reads get Pandoc verbosity 0 equals error. The next line reads get Pandoc verbosity 1 equals warning. However, Ang notes that many developers would prefer to write this as a single case expression. That looks more like a unified block, like case V of 0, error 1, warning.
Both methods achieve the exact same technical outcome, but the visual footprint and the structural syntax are entirely different.
Well, here's where it gets really interesting, because Ang explicitly writes that choosing between these two patterns often comes down to a matter of personal style.
Yeah.
I have to push back on this. We are talking about computer science. We're compiling strict machine code. If I allow developers to choose their own personal style based on what looks pretty to them, aren't I just inviting chaos into my code base?
How do you mean?
Well, code is just objective math. There should be one optimally efficient way to write it. If a team of 50 developers are all using their own personal artistic dialects to solve the same problem, they're going to create friction.
I see.
When I have to read your code, I shouldn't have to decode your personal aesthetic first. Shouldn't style take a backseat to rigid consistency?
You know, if the only audience for the code was the compiler, you would be absolutely right. But the machine is actually the least important audience for the source code.
Wait, what? The machine is the thing executing it.
Sure, but the compiler doesn't care about your formatting, your line breaks, or whether you used an equation or a case expression. It strips all of that away, reduces it to binary, and runs it.
Okay, fair.
Source code is written for humans to read. It is fundamentally a communication medium between developers. When you write code today, you are writing a manual for the next developer who has to fix a bug in it a year from now.
Oh, right.
And statistically, that next developer is going to be you, with zero memory of what you were trying to accomplish.
So you are saying readability is a defense against future bugs?
It is the primary defense. Code is read 10 times more often than it is written. Ang concludes that for this highly specific, simple example of translating a 0 or a 1, both patterns work perfectly fine.
Okay.
At this level of simplicity, the cognitive load is so low that the choice between a vertical list of equations or a branched case block is genuinely just human preference. It's like asking if you prefer reading bullet points or a numbered list.
But Ang doesn't leave us there. If both work fine for simple things, when does a developer have to choose one over the other?
Right.
Ang provides a specific roadmap for when the single case expression is no longer just an aesthetic choice, but a structural necessity.
Style gives way to architecture as the logic scales up in complexity.
Exactly. Ang points out that the real benefit of a case expression shines when dealing with complex logic that requires a do block. And then Ang drops some specific Haskell terminology.
Yes.
Stating this is especially true when handling types like maybe or either. In those scenarios, Ang writes, developers might need to use where clauses or let bindings to, quote, keep things tidy.
This raises an important question. To fully grasp why style becomes a necessity here, we need to understand what maybe and either actually represent conceptually.
Yeah, let's break those down.
These aren't just quirks of Haskell, they are profound ways of modeling the unpredictability of the real world.
Right, because a computer naturally wants absolute certainty.
Yeah.
It operates on binary logic. Yes or no, true or false, 1 or 0. But reality refuse to behave that way.
Exactly.
The network connection drops halfway through a download. A user submits a form, but leaves the email field blank.
And Haskell forces developers to explicitly acknowledge and handle that uncertainty at the structural level. The maybe type means exactly what it sounds like. This piece of data might exist and be an integer, or it might be absolutely nothing.
And the either type represents a fork in the road. Like, the result of this function will be either a success containing the document you requested, or it will be an error message explaining exactly why the conversion failed.
Introducing maybe and either means introducing multiple branching paths of reality into your program. You are no longer managing simple, predictable translations. You are managing stateful uncertainty.
And when you are dealing with uncertainty, the logic gets messy incredibly fast. You can't rely on simple one-line function equations anymore because every potential answer comes with a web of conditions.
Which perfectly contextualizes Ang's point about tidiness.
Think about a restaurant. If you are using those simple multiple function equations we talked about earlier, it's like operating a fast food drive-thru. It's incredibly linear.
Right.
Order 0 gets a burger, order 1 gets fries. You don't need massive infrastructure. You just need a window and a paper bag.
The inputs are predictable and the outputs are immediate.
But the moment you introduce maybe and either, you aren't running a drive-through anymore. Now, maybe the customer wants pickles, but maybe they have a severe allergy.
Oh, wow. Yeah.
The payment will be either a valid credit card, either cash, or it will fail entirely. Suddenly you have massive branching complexity. You cannot manage that out of a single drive-through window. You need a proper full-scale restaurant kitchen.
You need a contained environment that is designed to handle multiple simultaneous processes safely.
And that is what the case expression provides. And in that kitchen, you have specific prep stations. That is what ang means by using let bindings and where clauses.
Ah, I see.
You use a let binding as a prep station to chop the onions in one corner, and you use a where clause as a stove to pre-cook the sauces in another corner.
Right, right.
You organize the components so that when it is time to assemble the final dish, the final execution of the code, everything is ready. The case expression acts as the walls of the kitchen, creating a safe boundary where you can organize all of that chaos before handing the final plate to the customer.
That's a brilliant way to visualize it. The case expression allows the developer to isolate the complexity of real-world inputs from the rest of the application.
Yeah.
ang is demonstrating that as your logic scales to handle missing data and potential failures, your stylistic choices evolve into architectural load-bearing walls. You have to build the kitchen to keep the cognitive load manageable for the human brain trying to read it.
It's just wild. ang isn't just writing instructions for a PDF generator. ang is actively designing an environment that a human mind can navigate without becoming completely overwhelmed. And they are documenting this process in part 135 of a diary. It speaks volumes about the iterative nature of this craft. You solve a problem, and then you evaluate the architecture of your solution to see if it will hold up when the requirements inevitably change.
It replaces the illusion of technological magic with the reality of human craftsmanship.
It really does. So let's summarize the journey we just took through this notebook. We started with a highly practical goal, right? A developer trying to generate a tips PDF ebook who needed their foundational library, Pandoc, to stop acting like a silent black box.
And we saw how ang built a conceptual bridge, mapping raw integer inputs into structured logging states to force the system to communicate.
We looked under the hood at the code diff, examining how a developer has to physically wire those new concepts through the application's architecture.
Importing the vocabulary, widening the function arguments.
Right, and shifting from pure evaluation to sequencing side effects through a do block.
Finally, we explored the philosophical debate over aesthetics. We examined how something as rigid as compiled machine code relies heavily on stylistic choices to manage the cognitive burden of complex logic.
Yeah.
And how a developer uses structures like case expressions to build prep stations against the uncertainty of the real world.
Behind every app, every website, and every digital tool we interact with, there is a human being making millions of these micro decisions.
It's true.
Whether you are a seasoned engineer writing Haskell every day or just someone curious about the digital infrastructure of our world, ang's diary entry is a revelation. It proves that the seamless reality we experience on our screens is actually built on deeply personal choices about managing chaos.
Absolutely.
Which leaves us with a final thought for you to mull over. We've seen how a language as strict and mathematical as Haskell still requires subjective debate over style and tidiness. So the next time you open an app on your phone, ask yourself, how much of the software running our modern world is built on pure objective logic? And how much of it is just the personal, artistic signature of the developer who happened to write it that day?